I'm going to comment this so that if you want to run this, you can just uncomment, right? So there you have it. Catch me on the next one. What we want to be able to do is to send a message from customer, so this customer microservice, to the exchange, and not from notification to the exchange and then back to its queue, right? We've done that just to test things. Now let's actually send the message from the customer microservice to the exchange. So within IntelliJ, let's together open up the customer module, and then let's open up application.yaml, and in here we need to add in the RabbitMQ address so that we can connect to the correct instance. Now let's open up the main package for customer, and what we're going to do is open up customer application, and right in here let's basically say base, or actually scan base packages, so the way we've done with notification, and this will be com.amigos code. And then if I perform a search, customer, and then I also want, so duplicate that, and AMQP. So there we go. And there we go. IntelliJ was being slow for some reason. The reason we do this is so that we can basically have the ability to inject this producer. Now within customer service, let's say private, and then final, and then Rabbit MQ message producer. And if I put this full screen, so now we no longer need to send directly to notification, but instead, let me just extract this to a variable. And what I'm going to do is, so in here, let's just delete this. And now I can say producer dot and then publish. And the payload will be the notification request. Now at this point, the exchange, so this information lives inside of notification config, and we're going to refactor things a little bit, right? So this information in here lives within, so application.yaml, it lives right here. So exchanges, so all of this information that we need. So we need the internal.exchange and notification queue. So let's just go back to customer service, and this will be internal.exchange. And for the routing key, that will be internal notification and then routing key. So if I put this full screen so you can see what we are doing. So again, we're going to refactor things in a second so that we don't have to basically copy these values around, and we'll centralize these values so that everybody can use it. So now I can delete this because this is what we're doing, right? So adding to the queue, and job done. So also in here, I can see that we no longer need this client, and there we go. Now, if I go ahead and start customer, and also let me start the API gateway as well as fraud. So basically I'm starting every single application. So I already had the Eureka server up and running as well as notification, but now we should have all of these applications up and running in a second. So there we go. It seems that fraud is up and running, and basically what I want to test is this entire flow. So the request goes through the load balancer to customer, and then customer sends the request to fraud to check whether the customer is a fraudster, and then if it's not, it sends the notification to the exchange puts it inside of the queue. We haven't got this side just yet, but we'll get there in a second. So now let's open up Postman and let's send our request. So this is a very famous request to 8083. So this is the port that the API gateway is running. Let's just say send, and always the first request when I restart is really slow. But you can see that it took 3 seconds, but it's a 200 status code. Now, all I'm going to do now is just check whether we have this payload inside of our message queue. So let's open up the RabbitMQ management console and click on queues. We have one message which is ready. Let's just investigate, get messages, and indeed have a look. So this is the notification right here. So remember, you've seen this before. So this is actually stored in the database later, but this is what it's inside of this queue right here. And it's actually ready to be processed by the notification microservice. And that's what we're going to do next. All right, let's write some code so that notification can take messages off this queue. So currently we have one message that needs to be processed. So within IntelliJ, let's together open up the notification module and let's create a new package, and I'm going to call it RabbitMQ. And inside, let's have a class called notification and then consumer. Press enter. And this will be add and then component, or we could even say add service. So there we go. And what I'm going to do is have a method. So public void and then consumer. And within this consumer, I'm going to consume the notification and then request. So notification request. And let me put this full screen. There we go. And inside, what I'm going to do is, for now, let's just say private final and then notification service. So there we go. Notification service. And let's have the at all our constructors, and let's also have the at and then SLA for J, so that we can log in here. And here I'm going to log the fact that we consumed the message. So here, and then consumed from, and then queue. So after we log, let's also basically save. So notification service dot, and then we want to basically send, right? So pass the notification and then request. So you've seen this method before. So if I click on it, you've seen this method right here, which we're not using, Twilio nor any other API such as Firebase, but we're just directly storing this into the database. So now that we have this, and also I need to pass notification request in here. And there we go. So one last thing that we need to do is to say at and then rabbit, and then listener. Now the listener here takes, so queues. So we have to pass queues. And this queue will come from, so if you remember correctly, in our notification config, we have this right here. So rabbit mq.queues notification. So let's just take this, Control C, go back, and then we're going to pass the exact same thing. So there you go. Now, from the moment I start this application, this should immediately be invoked because we have a message in our queue. So remember this message right here. So if I click on queues again, have a look, we have one which is ready. So if I start the application or if I restart the application, then immediately we should consume that message. So let's check it out. So what I'm going to do is let's stop notification for a second. There we go. And let's put a breakpoint in here. Now let's start notification, but in debug mode. So debug, and hopefully we should stop at this breakpoint. because we've got a message in the queue and this listener will pick it up. So there we go. Fingers crossed, everything works fine. And ta-da! So I think this is it. So if I collapse, there we go. We've stopped in here, and what is going to process is the message that was on the queue. Have a look. So you see we had one message which was ready, but now it's basically gone. The listener has consumed it. So if I resume, so let me just remove the debug, resume, and in here, let's just go to console. Have a look. It did insert to the database, which is good. And we have a 200 status code if we try to send the request, which I'm going to show you in a second. So here, so let me just basically keep this breakpoint again. But if I reload, so what I want to show you is if I reload or restart, so this should not hit this breakpoint because there is nothing to be consumed at this point. And there we go. So you can see that it's actually starting and it's never going to hit this breakpoint because there is nothing to be consumed. If I go back to the management console, have a look. So now it's actually 0. And let's basically send a request from customer all the way and test the flow. So if I open a Postman and then send this request, there we go. And this brought me right into this breakpoint because there is a new message to be consumed. So here, let me just say continue or resume, and off you go. In here we have a 200 status code, which means that it worked. If I check the queue, there is nothing inside, so it's been consumed already. Now let me remove the breakpoint and let me send the request again. Send 200 status code, and you can see that we can keep on sending requests. And if I go back, go to the logs, you can see that we have a bunch of inserts in here and our system is working beautifully. So there we go. We've managed to do it. So all I want to show you also is, have a look. I think, yeah, so the consumer in here, you can see that we have a bunch of messages saying consumed, notification, ID 4, ID 3, 2, so on and so forth. So there you go. We've managed to do it. In the beginning of this section, you saw that if notification takes 20 seconds, then this microservice, i.e. customer, also takes 20 seconds. Now, what I want to show you is that as soon as we publish to the queue, it doesn't matter what happens on this side. So this can take 10 seconds, 20 seconds, so on and so forth. But as long as we know that this message has been put into the queue, then we can kind of guarantee that it will be delivered. So if I put this breakpoint in here and notification still running in debug mode, what I want to show you is that if I open a Postman, so if I send this request, check this out. So this right here is pending, but have a look what Postman says. Postman says that the request was successfully, and which is the case, right? So you can see that notification hasn't even processed the request, but we know that indeed eventually it will send the notification, and this is basically asynchronous, right? So this is what you've been learning throughout this section. So learning how to use queues, it's very important, and hopefully I've managed to teach you how queues work and more specific RabbitMQ, and now you can see the benefit of it. So here you can see that we don't have to wait for notification, because we've done, the essentials. We've checked that the customer is not a fraudster. And, if the notification takes 1 or 2 minutes, that is fine, right? Or the email. So that is fine. And right here, you can see that this is pending. This is pending. And eventually it will be delivered. So if I remove the breakpoint from here and then resume, you can see that eventually the notification was sent and we have a happy customer. By now, you should have a complete understanding of microservices, how to interact with each other, so on and so forth. Now, let's switch context a little bit and learn how we're going to start packaging up all of these microservices with Maven. The first thing that we have to do is to package up the microservice into a jar. So this gives us the ability to run the application from a single jar. Then what we're going to do is we're going to take that jar, package up into a Docker image, which you can run containers from. And then from that image, we can run a container within a Kubernetes cluster, but that's later. For now, let's just focus on understanding how we're going to package all of our microservices into a jar using Maven build tool. To kick off, let's learn about the Apache Maven compiler plugin. This plugin right here is used to compile the sources of your project since 3.0. The default compiler is Java compiler from JavaX if you are using Java 1.6, and it's used to compile Java sources. Now, it also says that at present, the default source setting is 1.6 and the target is 1.6. So I'll come back to this in a second. Now, let's open up IntelliJ, and within pom.xml right here, you can see that this is com.migos code. You've seen all of this. We've got modules. And if I scroll down, have a look, we have the build section, and within build, we have the plugin management right here. And then we have plugins. So this right here, so plugins, by default, all submodules will have this plugin installed. And then plugin management, whichever module that wants to use this Spring Boot Maven plugin, they can choose to do so. So right here, let's focus on this one. So Maven compiler plugin. So as you've seen that, so right here we are using Java 17. So I just want to make sure that the source is 17 and the target is also 17. Then also what I want to do is I want to specify a version right here. So if I say version 3.8 and I think 0 should be available as well. So let me just stick with this one. And right here, this is the configuration that we need. Now open up a MQP module and then open up pom.xml. And by default, this module will have this plugin right here, the Maven compiler plugin. So let me just go back to this module, and right here we don't need these properties, so let's just clean that up. But what we need is to specify the packaging. So here I'm going to say that the packaging for this is jar, and then remove this line, and this is pretty much all we need. Now what I'm going to do is from within IntelliJ, I'm going to use Maven. So let's just click on Maven in here. You should see that you have Amigo services, which is root, and then you have all of these submodules. So open up AMQP and then lifecycle and then plugins, and you should see that you have the Maven compiler plugin. So let me just reload Maven changes, and hopefully we should see the right version in here. I don't know if you saw this, but this did indeed update. So it was using the previous version, which was 2 or something. So let me just do that again. So you see, so if I remove this version and then reload, there we go. You can see it's using the 3.1 version, but I want to use 3.8.0 version. So let me just reload again from here or from here. And there we go. So this will allow me to package up this module. So if I close this and then I'm going to open up lifecycle, and if you have any target folders in here, just clean. So open up, so run clean, and you can see that build success. And now what I want to do is I want to just compile. And there we go. So build was successful. Now let's do the exact same thing for clients module, and in here open up pom.xml, and here let's also add in the packaging, and this will be jar, and let's remove properties from here because we don't need this. So it's as simple as this. Then reload, open up Maven, and let's do the same for clients. So lifecycle, and we have a target folder. If you want to get rid of that, just say clean, and you should see that this will disappear. There we go. Now I want to compile. At this point, I just want to compile just to make sure that things work perfectly. And there we go. So this also built successfully. Now let me collapse this. And if I open up the target folder, have a look, we have classes, and then we have the classes right here. So this is what we need to be included in all other submodules. So if I open up for target within AMQP, you can see that we also have the .classes file in here. And if you want to see whether it's a class or not, so let me just collapse that, click on that. And right now, basically, if you open it, just decompiles directly. But what I want to do is I want to go to view and then show bytecode. And this is the bytecode right here, which probably doesn't mean anything to you, but I'm just showing you that this is the class file. So this is the raw class file right here. So if I close this, now if you want to generate the jar for these two modules, open up the Maven tab, and in here, just click on package. So we'll learn about install in a second, but for now, let's just package. So I'm going to package clients. There we go. So you can see that was success. And if I look in here, now have a look, we have the jar file. So clients 1.0 snapshot.jar. Now for AMQP module, there's no jar. So let's generate that as well. So in here, let's just open up the AMQP module and then say package. And we should see a jar in a second. There we go. You can see that we have the jar file. This is pretty much everything for the Maven compiler plugin. Next, let's learn how we're going to take all of our microservices and package them using the Spring Boot Maven plugin, because these are microservices. So API Gateway, Customer, Eureka Server, Fraud, as well as Notification. If you have any questions on this, drop me a message. Otherwise, let's move on. Okie dokie. Now let's learn how to package up our Spring Boot applications, Customer, Eureka Server, Fraud, as well as Notification. So let's go back to our main POM right here. And you know about this plugin, which is included to every single module. And you might be wondering whether if we package up the Spring Boot application with this plugin, then we might be able to run the application. Well, not quite, right? Not quite. So Spring Boot, they actually gives us, so right here. So if you have noticed, we have this Spring Boot Maven plugin. So let's just find out what is this. So in the official documentation right here, so you can search for Spring Boot Maven plugin documentation. So this Spring Boot Maven plugin provides Spring support in Apache Maven. It allows you to package executable jars or WAR archives, run Spring Boot applications, generate build information, and start your Spring Boot applications prior to run integration tests. So they make it super easy for us to get started. And right here, so all we have to do is just add in this and off we go. Now, if you remember correctly, so using the plugin, so if I scroll down, so have a look. So when we did set up the project, we are using the Spring Boot without the parent POM. So in here, they have this section, packaging executable archives. So let's just click on that. And this takes me right into this page right here. And right here, the plugin can create executable jar files. Packaging an executable is performed by the repackage goal as shown in the example. So have a look. So it's shown in here. So this is how we use the plugin. Now, because we're not using the default parent POM, which gives us this by default, we have to have this tag in here in our POM. So in here, if I go back to IntelliJ, you can see that we are defining the plugin ourselves in here. And what I would like to do is just to include the phase, right? So, or actually the execution. So you can see that the execution has one goal, and the goal is repackage. So basically, after packaging the application using a Maven compiler plugin, then it goes and then it repackages so that it can basically run the Spring Boot application. Now, without this, we won't be able to run the applications. So now all we have to do is the following. So let's just basically take this name in here and let's open up our microservices. So let's start with the API gateway, which I forgot to mention before. But open up pom.xml, and within pom.xml, let's also mention that we want the packaging here to be jar. Let's remove this guy in here. And then let's have the build tag. So I'm going to say build. And then within build, let's have plugins. And then for plugins, let's have the plugin. And this will be artifact. And then paste that artifact. And this will come from org.springboot. So this is group ID. And basically all I'm doing is just taking this. So I could have just copied all of this, right? Command C, go back, and then paste this in. And you can see that this now refers to the parent module in here. And there we go. So now in our sub modules, we don't have to have this executions because we're just using this plugin, which is already configured. And to be honest, this is it. So now let me just go back in here and I'm going to take this build, Command C, and then paste it in all of our microservices. So customer, scroll down, let's have the packaging as jar, and then let's paste the plugins there, or the build and then plugins. Let's also remove properties, we don't need that. Then let's do it for Eureka server, open up pom.xml, and then packaging jar, and then remove properties and put the plugins in here. Let's also do the same for fraud. And I don't know why this is here, but this shouldn't be here. So let's just remove that. And then this as well. And packaging jar. And then put in the build with the plugin. And finally, notification. So packaging jar. And then we can get rid of properties. There we go. And then add in the build. And off we go. Now the last thing that I need to do is just to load Maven changes. And off we go. So So let me basically close all of these files. So close all tabs, and I think we are good to go. Next, let's learn how we're going to install everything. So we are almost there. And what I want to show you is that if I open up Maven, and then let's try, and in here, let's open up customer, lifecycle, and then let's just try to compile customer and see what happens. So this gives me an error right here, and the error is missing, so no dependency for AMQP and clients. So remember, I said that these are dependencies for our project, correct? Now, the reason why this is not finding them is because we did not run yet Maven install. So let me just demonstrate to you what it means. Let me open up my terminal, and within my terminal, let me type cd, and here if I say pwd, I'm in the root of my user. Now here I've got a folder called .m2, so cd .m and then 2, there we go. And inside of m2 I've got a folder called repository. If I cd into repository, now let me type ls, and this basically contains all the build artifacts. Now if I cd into, so basically you can see that this follows the package folder structure. So let me just navigate to cd and then com right here, and if I type ls, so currently you don't see that I do have anything with Amigos code. And this is why in IntelliJ, if I open up, I think it was the run tab in here, so it says that customer cannot run because the AMQP as well as clients jar snapshot are missing. So no dependency information. So what I'm going to do is, so open up AMQP and then lifecycle and then install. So what install does, so in here I've got the official documentation for Maven, and within the build lifecycles basics, I'm going to give you this link actually so you can follow along. But if I scroll down, have a look, install the package into the local repository for use as a dependency in other projects locally. So this is what we want. Whenever you want to start fresh from a project, you basically, so you open up the root and then lifecycle, and then you perform a install. So in here, so you perform a clean. So let's just clean everything first. So you could do this through the terminal by using Maven clean install, or through here. So here, I'm just going to now say install. So this now should install all the modules for us. So just give it a second. So you can see that it's building a bunch of things. And there we go. So build success. Now have a look. So all of these modules have been successfully installed. So what I'm going to do is go back to my terminal, and then still within com folder. Now if I type ls, check this out. Now we have Amigos code, and now I can say ls and then Amigos code and have a look. So we have all the modules. So we have Amigos code services, API gateway, client, customer, so on and so forth. So let me cd into Amigos code and then AMQP. There we go. And then type ls and have a look. We have 1.0 and then snapshot. Now this right here should be familiar. So within IntelliJ, if I open up, for example, customer, pom.xml, and have a look. So we have this dependency right here, right? So within, so if I collapse this, you can see that we have this dependency as well as for clients. So 1.0 and then snapshot. So also, I just realized that by default it's compiled, but let's always enforce this scope and then compile. So now we can open up this Maven tab, and then in here let's just try to basically compile, oops, not there, but here, compile customer. So before we couldn't, now let's see if we can. So compile only customer, and have a look. Now it does work. So this is something that you have to bear in mind. So always first you need to install. So you need to install from the root so that everything gets installed to the local repository, so you can use the modules as a dependency in other projects. So what we have achieved is the ability of installing from the root POM right here. So this we can install from here, but also we can install individual modules. So if, for example, your team is working on the customer module right here, you can basically install the jar independently from my team. Let's say my team works on fraud, and maybe I just want to release fraud. Then I can basically just say, right, so let's just compile, and I can even package, so on and so forth, independently, right? So if I also say compile in here, I just want to show you that this should also work. And there we go. So there we go, we've done it. Next, let's run all of our microservices. Okie dokie, so we've managed to achieve all of this. So we took our code, i.e. our microservice. So let's just say this is fraud, and then we've packaged up into a jar. Now, where is this jar? So whenever you run install, it actually also packages up your application. So if I open up the module, so any module, you should see that we have a target folder. And within target, we have the jar in here. Have a look. So we have this jar. So also, let's open up API Gateway, target. So here we have jar and jar.original. And this is because the jar.original, so here, so it's because of this plugin that we have. So if I collapse this, it's because of this plugin right here. So Spring Boot Maven repackage right here. So when it performs a repackage, it renames the original jar to jar.original, and then this is the one that we should be running. So I'm going to show you this in a second. So if I close this, so here we should have clients as well. We have a target, so only one jar because we're not using the Spring Boot Maven plugin. Customer also should have it. There we go. Eureka server. There we go. Fraud. There we go. And also notification. Now in here, so if I open up Maven, and if you only want to, so let's say that within customer, let's just clean customer. So here, clean customer jar, and this should go in a second. There we go. So if you just want to package, so package meaning that you want to get your jar out, you don't have to run install. So you could just say package. There we go. And have a look. So now we have the jar in here, right? So it's the same thing, but sometimes people get confused about package and install. So now what I want to do is, so right within IntelliJ, let's just use this terminal because we can open up multiple terminals. So here, let's basically run our microservices. So you could run the microservices in two ways. One is using the Spring Boot Maven plugin. So in here, you can say Maven and Spring Boot run. But what I want to show you is how to run using the traditional java-jar. So in here, let's kick off our Eureka server. So java dash and then jar, and then Eureka server, target, and then if I press tab, we have the Eureka server, one snapshot and then jar. So let's just run this, enter, and you should see that this should kick off and have a look. So it's starting. So this is what you've been seeing throughout this course, but now we're actually running the jar itself. So once this is up and running, we can run all the other microservices. So here I'm going to say java-jar, and then let's start with customer, and then target, and then let's run customer, and then the jar. So you can see that the original doesn't show up in here. So oops, I want to run this, run, and hopefully the Eureka server, there we go, it's up and running. So my font is kind of big, but you shouldn't see this massive font. So here, if I open up customer, just give it a second, and there we go, creating the table as you've seen before, and there we go. So it looks like it's up and running. So Tomcat started on port 8080. Now let me open up my web browser and then open up the Eureka server. And before I had all of these up and running through IntelliJ, but now if I reload, check this out, we only have customer up and running. So this is really cool. Now let me start the rest of applications. So new tab, java-jar, notification, target, and then the jar itself. And right here, I'm running this from within the root of Amigo services. So run notification. Let's also run fraud. There we go, enter. We also need to run the API gateway, and then press enter. Okie dokie, up and running on port 8083. In here, let me reload, and you can see that we have all the microservices up and running. And obviously I've got the RabbitMQ, Zipkin, the database, everything is up and running. So now let's basically test the request to our API gateway. So within Postman, let's send the request to 8083, and this is our familiar payload. Send, and fingers crossed this should work. And there we go, we have a 200 status code. So let me open up Zipkin, and then let me search for service name, and then API gateway, run the query. So this was just now, a few seconds ago. So 8 spans, show, and have a look, it's working beautifully. So from the API gateway to customer, customer talked to fraud, and then customer did publish to the notification queue, and it received an acknowledgement back saying that things worked. Let's check the database. So here, let me just reload or refresh this server. So I don't think I did connect. So yeah, so I need to put my password. There we go. And all I want to see is notification, because I know the rest indeed did work. So notification, and then we have schemas, and then public. Within public, we have tables, and then we have notification. There we go. Right click on notification, and I want to view all rows, and there we go. So hi Jamila, welcome to Amigos Code. Let me send another payload. So here I'm going to say Amigos, and then code, and then this is hello@amigoscode.com. Send this request 200, and then replay the exact same query, and there we go. Hi Amigos, welcome to Amigos Code, and the sender was Amigos Code. So you can see that everything is working beautifully. And also let me just show you the logs. And what I want to show you is, so I think this is fraud, and I want to see the notification. Yeah, so notification is where we have the queue, right? So let's see whether we can see consumed. Yes, have a look. Notification consumer, consumed notification request, and this is the notification that was sent. So there you have it. You can see that we've managed to take all of our applications and package them correctly, and we can run them independently. Next, what we have to do is take the jar files and then package up into a Docker image. If you have any questions on this section, please do let me know. Otherwise, let's move on. And what I'm going to do is stop all of these applications. So stop. I'm just pressing Control C on all of them. So Command C, and there we go. So I think all of them stopped. There we go. And I can close all of these tabs. So close all tabs and job done. So you can see that we've done a very good job in this section, and we can move on. But as I said, please let me know if you have any questions or anything that wasn't clear. Catch me on the next one. So we have everything configured and set up. Now let's take the jar and package up into a Docker image. From that Docker image, we can then run containers, and you'll see the benefit of Docker. If it works on my machine, then it surely works on your machine. Docker is a technology which has changed the game in terms of the way that we package software. And later you'll see with Kubernetes, it's the perfect match. If you want to learn more about Docker, I've got a complete course on Docker explaining everything in detail. But in this section, don't worry, because I'm going to simplify the process, teach you the core concepts of Docker, and make sure that you have the required knowledge to take your jar, package up into a Docker image using Jib. So we're going to use Jib. And then from that, we can run containers. And the containers that we're going to run are within a Kubernetes cluster. So I'm super excited about this section. Let's kick off. Let's begin by understanding what exactly is a Docker. Docker is a platform for building, running, and shipping applications. I think this bullet point really tells what Docker is in one single sentence. Now, bearing that Docker is a platform for building, running, and shipping applications, developers can easily build and deploy applications running in containers. Now, more in detail on containers, but you can think of a container as a running instance of our application, packaged up and running within a container. The cool thing with Docker is that local development is the same across any environment. Have you had this scenario where it kind of works in your machine, but it doesn't work on the development environment or staging environment, demo environment, production environment because of hardware issues, installation issues, configuration, so on and so forth? Now, Docker removes all of that away. If it works on your machine, it will work in dev, staging, demo, pre-prod, prod, and basically any environment. Docker is also used a lot for CI/CD workflows, so continuous integration and delivery workflows. So we're going to touch more on CI and CD workflows later in this course, but just bear in mind that Docker is used quite a lot in the DevOps space. So let me teach you about Docker images and containers and basically how everything fits together. So how do we go from some code that we have to running a container? Now, usually when building software, you have your source code. So this could be pretty much any code written in any programming language. Now, what you as a developer do is you take that code and then you build a Docker image. Now, from this Docker image, you can run a container. So from the Docker image, you can run a container. The Docker image, you can think of it as the template for running your application. Now, the cool thing is, from one Docker image, you can actually run multiple containers. So here, for example, you can see that the container is a JavaScript application or Nginx or Postgres or pretty much anything that you want. Literally any programming language, any technology that you're used to, you can pretty much just run it as a Docker container. So a Docker image is basically a file used to execute code in a Docker container. It is a set of instructions to build a Docker container. So you've seen that from our code, we can build the Docker image, and from an image, we can run containers, right? So this is the purpose of the Docker image. From it, we can run multiple containers, right? So it contains the application code, libraries, tools, and everything needed to run our applications. You can think of a Docker image as the blueprint. And from the blueprint, we can run multiple instances of the actual thing that we want, which are containers. So a container is an isolated environment for running applications. So that's literally what it is. So this is a container. Now, this might not tell you exactly what the full picture is, but let me just go inside and tell you what the container is. So within a container, it contains everything that your application needs. It contains the operating system, it contains the tools, and also, most importantly, it contains the software. So here, let's say that this is a Spring Boot application, or it could be a JavaScript application, a Node application, a Golang, a Python application. It could be literally any application that you have. So it contains the operating system, tools and binaries, and software. So when we run the command docker run, and then I said amigos code /2048, so what that gave us, it gave us the application right here. So on the left hand side is the container, and then on the right hand side is the actual application that the user interacts with. By now you should have a pretty good understanding about images and containers. Now let me make sure that you fully understand the Docker architecture and how things fit together. So the Docker architecture follows the client-server approach, where the client is the CLI that we've been using, and the server is the Docker host. So this is where we have Docker up and running. So you've seen that we installed Docker locally. And also we have registries. So this is where, for example, you've seen we can use public images or private images that we're going to learn later in this chapter. But basically, inside of the Docker host, we have something called Docker daemon. And the Docker daemon is responsible for handling requests from the client. So here, for example, you've seen Docker build, Docker run, Docker pull. Actually, you haven't seen Docker build. So you've seen Docker run and Docker pull. But the build command, this is where we learn about building custom images later in this course. But here you can see that we issue a command that is sent to the Docker daemon. And I'm going to explain more on the Docker daemon, and I'm going to show you exactly where you can find all of this. But let's say that we want to run a container. So when we run a container, if the container is not present on the host, then Docker daemon goes and fetches from the registry. So here, this is where we have, you saw Docker Hub has over 8 million images, right? So it goes, it fetches the images, and then it stores it on the host. You've seen that when we say Docker image ls, you see the list of all the images. So here, let's say that we have a Spring Boot image, for example, or a Postgres database image locally. And from it, we can run containers. So here, let's say that we want to run a container for the Spring Boot application, for example, and another one for the database. And later you'll see how we're going to use, for example, Docker Compose to have two containers where we have the front end and then the back end, where the database will be actually a MongoDB. But you'll see how everything works. But basically, in a nutshell, this is what is happening. I felt like teaching you first containers and images would make more sense, because now when you see this, you now understand exactly what's happening under the hood. Next, let me explain you more about the Docker daemon. You've learned about the Docker architecture, and early in this course, remember we spoke about Docker registries. Now, in this section, let's understand exactly what Docker registry is and how to work with public and private registries. So a Docker registry is a storage and distribution system for Docker images. Now remember, throughout this course, I've showed you Docker Hub, and this is where you saw the list of all images. So about 8 million or so images. It's called Docker Hub. Now, when it comes to Docker registries, we have two types. We have public or private. So I'm going to show you exactly the difference here, but basically a public means that your image is publicly available. So if you've seen, for example, Postgres, Node, Python, pretty much all the images that we've been using, they are public. So anyone can pull those images and basically just do whatever they want to do with it, right? So those are public images. Now, private images are images that you have full control. So maybe you are building your own software and you don't want to basically allow other people to run your own software, right? So this is where you have a private image. So I'm going to show you how to create both public and private repositories in a second. So basically, you've seen that we've issued this command. So docker pull. Now this pulls an image to our local machine, so to the host. But also we can take an image that we have and we can push to Docker Hub or any registry really. So let me show you some of the available Docker registries which are quite popular. So here you saw that we have Docker Hub in here, and you've seen this already. So if I click on explore in here, you can see that this contains a bunch of images here. So over 8 million available images for you to download. So MySQL, Java, Couchbase, Postgres, Node, Python, OpenJDK, Golang. So a bunch of images, including Nginx, RabbitMQ, so on and so forth, right? And you can see the downloads in here are quite high. So Docker Hub is the most popular public Docker registry. Then you have other Docker registries such as ECR, so Amazon Elastic Container Registry. So for example, if you're working within the AWS ecosystem, then it makes perfectly sense for you to use ECR for your private or even public registries, as you see here, public or private, right? You also have Container Registry, or more specifically GCR, so Google Container Registry, and this is from Google, so GCP, Google Cloud right here. And also it's quite popular, and you can store both public and private images. Then you have GitHub packages. So this is quite recently, to be honest, but still quite popular. And GitHub, to be honest, they are doing an amazing job bringing a lot of features into the ecosystem so that you don't have to leave their platform. So here, if I scroll down, you can see that they have Docker. You can also store npm packages, Maven, NuGet, and Ruby gems. But basically, we are interested in Docker in here, and they give an example, for example, how to log in and then tag. So you've learned about how to tag, so on and so forth. And here you can see how to push, for example, a Docker image. So don't worry, I'm going to teach you everything that you need to know in order to authenticate and push to Docker registries. So for this course, what we're going to do is we're going to use Docker Hub. This off now, catch me on the next one. So in here, navigate to hub.docker.com, and what I want you to do is to create an account in here. So if I click on sign up, you can see that here you can create an account, but I already have an account, so I'm going to sign in, and my Docker ID is Amigos Code, and then I'm going to add my password. There we go. Now I'm going to sign in, and in this page right here, what it's showing me is my repositories. So have a look. I have this public repository, this one here. So this is the game that we, that you played with, right? At the beginning of this course, 2048. Then this one was a mistake actually. And then this was actually for a tutorial in here. I've said /private. And then there's one for Kubernetes in here. And if I scroll down, one for website. So I don't have many repositories, but here you can create as many public repositories as you wish. So you've seen that if I open up my terminal, and in here, if I, for example, so you can even type together. So you can say docker and then pull, and then here, amigos code / Kubernetes. So have a look. So in here, if I go back, so this is amigos code / Kubernetes. And if I open, you can see that I do have a bunch of tags in here. So I've got, for example, a front end, I've got a couple of microservices in here, but let's say that I want to basically pull the front end. Here, I can just say column. So this is the tag that I have, and the tag was front end dash and then v1. Enter. And you can see that I'm able to pull this image, right? Now you can pull any public image you can pull without authenticating. Now in here, so what I have is, so if I come here for a second or go back for a second, in here I do have this repository which is private right here. So let me go back for a second, and then here I'm going to say, so let's just pull amigos code and then private. Now let's see what's going to happen. Have a look. So error response from daemon, pull access denied. And this is because I'm not authenticated through the CLI. So to authenticate, we can say docker login and then -- help, and have a look. So here we can pass the password, and we can also pass the username. And you can also log into Azure in here. So what I want to do is, let's just say docker and then log in, and you'll see that this will actually take the username from standard in. So if I press enter, have a look. Now it's asking me for my username. So amigos code and then my password. And there we go. You can see that now login succeeded. So what I'm going to do is I'm going to pull amigos code / private and have a look. You can see that by default, if you don't specify a tag, it gets latest, and you see that this worked. So this is how you authenticate yourself against Docker Hub to pull private images, right? So for example, if you are using ECR or GCR or even GitHub packages, the authentication process is a little bit different. But you can see here, for example, this is how they recommend you. So you say doc login, and then you specify the actual registry, which is ghcr.io, and then you pass the username and then a password. So you can see that it's a little bit different, right? But for Docker Hub, we can just say docker login in here. So if I say help as well, or again, you can see docker login, and basically you can then pass the password. So you can pass the password, well, actually, my bad. You can pass the username right here, and you can say take the password from standard in. Now what I want to show you is, so in here, let's together navigate into CD and then the root of your user, so the root, and then in your root folder, so in here I'm already in my root folder, you can see that I do have dot and then docker, and in here if I type ls, have a look, we do have this config.json. So if I say cat and then config.json, there we go, have a look. So you can see that auth in here, this is https index.docker.io, and then the cred store is desktop. This is how you can configure the auth credentials for the corresponding Docker registry. So if you have any questions on authenticating, please do let me know. Otherwise, catch me in the next video. All right, now that you have the understanding about Docker, container, and images, what we want to do is to take our microservices and then put them into a jar, which we already have. Then we want to build an image. And then from this image, we can run the application itself. There are a couple ways that we can build Docker images. One is to use the Spring Boot Maven plugin, and in here they have packaging OCI images. So the plugin can create an OCI image from a jar or war file using cloud native build packs. And then here they give the example on how it works, and it's really straightforward. So in the Maven plugin, all you do is you just say executions, and then within you have one execution, and then you have one goal, which is build image, and this will build a Docker image for you. Now here you can pretty much just go and read more about it. You can pass environment variables, so on and so forth. But what I want to do is, instead of using Spring Boot Maven plugin, I'm going to use Jib. And Jib is a really great tool, and this is from Google, I believe. And basically it allows us to build or actually containerize our Java applications. You can read more about it. So it's available for Maven, Gradle, and the goals here, they say that it's really fast, reproducible, and daemonless. So on my Spring Boot full stack, I cover all of this in detail and how it works. But let's use Jib, and also here you can read more about how Jib works, on and so forth. So I'll leave this up to you. Now the benefit really of using Jib and also Spring Boot Maven plugin is that there is no need for you to write your own Docker files. So I think they even mentioned here. So no more writing Docker files and calling Docker build and push. Now if you want to learn how to set it up, you can see that they have quick start here. And also they have examples for Spring Boot applications, multi-module projects, so on and so forth. So don't worry about this, because I'm going to take you through right now how we're going to set this up. But you can click on any of these links. So Maven, for example, and you can see that they give you the example by using plugins, and then you can have the configurations, so on and so forth. Next, let's go ahead and integrate Jib in our project. So within our main pom.xml, what we're going to do is to add a plugin within plugin management. So the same way that we've done with Spring Boot Maven plugin, what we're going to do is to add in, so let me just collapse this for a second. So this one. So we're going to add in a second plugin in here, and this plugin will be Jib. Now the main reason why I'm not putting it inside of this plugins section here, so plugin section, is because I don't want every single submodule to have Jib. So I will let only the modules that need it, i.e. our microservices, to then include them in their POM file. So within plugin management, let's have a plugin, and let me just put this full screen right here. So let's just have a plugin, and this plugin will be Jib. So here I'm going to add the artifact ID, and the artifact is Jib dash and then Maven dash and then plugin. Now this guy here comes from the group ID of com.googlecloud.tools. Let's also specify the version. So in my case, let's use 3.14, and I believe is the latest version as I speak. So make sure that you stick with the exact same version as me so that everything works beautifully. Now that we have this plugin, let's define some default configuration for all of our microservices. So here, let's have the configuration tab, and within this configuration tab, I'm going to specify the from. So from here, we have to basically specify the base image that we want for our Java applications. So we are using Java 17, and what I'm going to do is navigate to Google and type adopt OpenJDK and then Docker. And here, if I click on this very first link, so this is pretty much the official image for adopt OpenJDK. And what I want you to notice is right here, they say that it's deprecated. Right here, they say that it's deprecated. Now they say that this image is officially deprecated in favor of Eclipse Turmeric. Again, Eclipse Turmeric. So before we used to use this image right here. So adopt JDK and then whatever version that you want, either 11, 12, 15, 16, so on and so forth. But now they're recommending us to use this one. So let me just click on this, Eclipse Temurin. And right here, if I scroll down, you can read more about it, but it provides us with runtime environment images that we can use. So here you can see that it's really straightforward, and all you'd say is Eclipse and then dash Temurin and then column and then the version that you want. So let's use this in our pom.xml. So here say Eclipse and then dash Temurin and then column and 17. Now, one thing that I'm going to include in here is the hash. Now, because I want you to use the exact same image, i.e., if this image was to change, for example, in the future, I want to stick with a particular hash, which I know indeed works. So under the description of this video, you'll find the exact full image. But here I'm going to paste the hash, which is a long number. So it's at and then SHA. Oh, actually, my bad. So I meant to say SHA, right? So this is the SHA 256 and not the hash. So SHA 256 and this right here. So is just to make sure that we use the exact same version. Even though this image changes internally, we are guaranteed to use the exact same. And also this is the best practice for Docker anyways. So now we have the from image. So this is the base image. Next, let's have the platforms. So inside, I want to specify plat and then forms. And this is so that because I'm using the Mac M1 chip, so I want to build for different platforms as well. So AMD Linux. So here I'm going to have one platform and this will take the architecture. So architecture, and this will be ARM 64. So this is what I'm using right now. And then the OS will be Linux. And let's also take this so that if you decide to basically run my image, you can do it. But instead, this will be AMD 64 instead of ARM. So AMD 64. And to be honest, this is all for the from configuration. Now let's specify the to right here. So this is basically the image that we want Jib to build. Now for every single image, I want Jib to have this tag right here. So tags, and inside I'll have one tag, and this will be latest. So every time we build an image, we want to have two images. So we want to have latest, and also if I scroll up and if I go to properties in here, so Jib expects us to have this property right here called image, and this is the name of the image that we will produce along with latest. So here, let's say amigos code / and then $ curly brackets. Then here I want to have project dot and then artifact ID colon and then the version. So this will be $ curly brackets and then project dot, and then you can actually use build. So if you have a specific build that you have, but for now, because we're not configuring Maven to its full extent, let's just use the version in here. So let's just use version. Or maybe if you have a build number that comes from TeamCity or GitHub Actions or others such as Jenkins, you can definitely pass this in here. But in our case, we're not using none of that at this point. So let's just stick with this. And to be honest, this is it. So basically, you can think of this as, so this will be, for example, amigos code, and then the artifact ID will be customer, for example, and then the project version. So I think it's snapshot currently, snapshot, and then blah, right? So if I open up customer right here, and then actually pom.xml, so have a look. So it's just taking the artifact ID, which is this, and then the version right here. right? And also, if you want, you can combine with the artifact ID from the parent, so on and so forth. But basically, we are centralizing the image name. So if I close this, so we are centralizing the image name right here. So this will be customer, and then we have fraud, we have notification, API gateway, Eureka server, so on and so forth. And you'll see how this will work in a second. But to be honest, this is the configuration needed. You can also find this under the description of this video. And if you want, you can take these and put them as properties if you want. So the same for the version, so on and so forth. So now that we have the base configuration, next let's add in the configuration necessary to our sub modules right here. So customer, API gateway, fraud, Eureka server, and notification. Catch me on the next one. So within plugin management, we have this plugin right here, which we've just added, Jib Maven plugin. Now the sub modules can decide how they want to use this plugin and if they want to use it at all. So for AMQP as well as clients, there is no need for them to include this. So therefore, we don't have to touch these. Now, customer, API gateway, Eureka server, fraud, notification, we want to build a Docker image for those. So let's start with API gateway in here, and then the rest of the configuration will be the same for all other modules. Now open up the pom.xml, and in here, what we're going to do is right after, so in here, you can see that we have build and then dependencies. So what I like to do is, so right after build in here, let's have a profile or profiles. And within this profiles, let's have one profile, and we're going to name it as build Docker and then image. And in here, let's have the build. So here, this will be the exact same thing as this one right here. So build, and then inside of build, we have plugins. And then inside of plugins, we have our plugin. So in here, so we have this plugin, which we've just added. So if I take this and then go back, and here, let's just say plugin. So we want to have one plugin, and then paste it and have a look. This now comes from the parent module, which is really, really cool. Now, one last thing that I want to do is I'm going to say executions, and I want to execute this plugin. So execution and then phase. So after we package, I want to run. So I want to run this goal right here. So I want to say goals and then goal, and inside of this goal, I want to say build. So this plugin gives us a couple of goals so we can build, and this will build the image and push it to our Docker registry. We can build a tar, and we can also build locally. So Docker build, this is building a local Docker image. Now here, I'm going to pick build, just like that. And the reason why I'm not building locally is because currently, as it stands, so because I've got this platform right here, it doesn't let me build locally. So I just have to push it. I think it's a bug right now, but hopefully they'll fix it in the near future. Now, if you want to use the latest version, just remove the SHA in here. Just remove the SHA in here. So to be honest, this is pretty much it. Now, this executions right here, you can actually also centralize this. You can say maybe for every single microservice that wants to use this plugin right here, the execution will be in the build phase, maybe, right? Or you can let them decide how they will build their Docker images. So for now, it's really up to you. You can take this. So if I was to take this and then put it in the parent, so here, after, I think, yeah, so after configuration, I can just paste that in and then just leave it here, and you can see this is now much cleaner. So I'll let you decide what you want to do. So let's just leave things as is right now, And what I want to do is, let me just reload these Maven changes. There we go. And open up Maven. And right here, you should see profiles. And we have this profile, which is Docker build image. So this is cool. Now, if you want to run and test things, you can actually do it from here. So you can just select this. And then when you run package, so currently for API gateway, so if you run package, then we should see that the image gets built. So let's actually do that in the next video. Okie dokie. In order for us to test these changes, we can actually select this profile. And then in here, open up API gateway lifecycle. And then you can just click package. So if you double click package, this will run. Now, before you do that, what you need to do is the following. So you have to make sure that you are logged in. So if I open up my terminal, and then in here, if I type pwd, I think I need to, so I need to navigate to desktop. So cd, and then tilde, desktop, and then amigos, and then services, and there we go. Oh, actually, you don't have to be in this folder in order for you to perform a Docker login. So remember before I said Docker login, and what I want to do first is log out. So you see, so Docker logout again. So this now remove the credentials. And if I want to push an image to my Docker registry, it won't work. So here, let me just say Docker login, and then it asks the username and the password. And there we go. So login succeeded. Now at this point, I can run this package right here. But also, what I want to make sure is that you don't have, so if I go to the main POM in here, if I scroll up, so this image right here, so amigos code, so this has to be your Docker username. Again, this has to be your Docker username. Otherwise, it won't work. You can't push to my account. So change this to your Docker username, as you've seen in here. So I've logged in with my Docker username right here. So that has to be your Docker username. So from this point onwards, we can pretty much cd into API gateway. So API gateway, and here we have the POM ls pom.xml, and now I can type mvn and then clean package and then dash and then capital P for profile Docker build image. So this command right here is the exact same thing as if I was to open up API gateway, also select this profile and then run package. So I'm just showing you a different way of doing things. So at this point, I can just press enter and hopefully this should work. And as always, demos do fail. So it says the requested profile Docker build image doesn't exist. So let's have a look. So this is build Docker image and not Docker build image. So my bad in there. So clear this, and then this should be build and then Docker image, and remove this. There we go. Enter, and let's watch. So have a look. So using credentials, and it's pushing. So 81%. So just give it a second, and just give it a second. So this will take a while, but basically it's just pushing. There we go, and build success. So this is amazing. So you can see that it took about a minute, and we've pushed the image. So build and pushed image as amigos code API GW column and then 1.0 and then the snapshot. But also in here it did, and also it did push latest in here. Now let me navigate to Docker Hub, and in here, So you can see that I have no images for API gateway or any of the microservices. So let me just reload, and hopefully we should see that we have this new image. Have a look. A minute ago, API and then GW. So if I open this up, and in here we can see a couple of things. So one, we can see that we have two tags. So one is latest, the one we've configured, and then the 1.0 snapshot. So also tags, and here you can see the information even better. So this is one tag, the digest, the OS architecture, so these two, and the same for latest. So there you have it. If you have any questions, please do let me know. Otherwise, catch me on the next one. All right, so you saw that from within API Gateway, we can run Docker Maven clean package and then select the profile and then build image. Now this profile, if I remove it and just say clean package, it will not push. Have a look. You can see that this was quick and it didn't push the image to Docker Hub. Now what I want you to do is, so I want to set you an exercise from the root of your folder, i.e. microservices. So cd and then dot and then type ls -al. So here you can see that we have basically all the microservices, and we have the pom.xml. Now if you type maven clean package -p from this point, is just going to build and push this application. And what I want you to do is to include the necessary changes for all of these submodules so that they can also be pushed, i.e. we can push all in one go, or we can build and push all modules in one go, or individual modules as you saw with this one right here. So effectively what you have to do is, so basically take this configuration right here and then share it across all the necessary submodules. Give that a go, and I'm going to give you the solution in the next video. All right, so all I've done was I took this same configuration which I had within API Gateway, and then I've basically put it inside of the POM XML for customer, Eureka server, fraud, and notification. And with this, what we can do now is, if I open up my terminal, or you can do it through here if you want. So you can basically select this profile and then open up the root and then lifecycle, and then you can say package. But let me open up the terminal because it's easier for you to see the results. So in here, if I clear the screen and I'm inside of Amigos services folder, so this is the root, and all I'm going to do is just run this command, maven clean package, and then -B to activate the profile and then the profile name. Now I'm going to press enter and just give a second. You can see that it's actually pushing through things. Now this should take some time. And it's taken a while, but here you can see that it's doing notification. And ta-da, you can see that it did finish. So have a look, build success. And it took, right here, it took almost 5 minutes. And you can see for clients as well as AMQP, so these two modules, it actually didn't take that much. So they were super quick. But for the rest, because they had to build the Docker image and then push, each took about a minute or so. Now let me open up Docker Hub, and if I navigate to repositories, So before, remember, we only had API gateway, but now if I reload, we should see all of our microservices in place. So reload. And have a look. We have API gateway, notification, Eureka server, fraud, and customer. So this is really awesome. So if you managed to get this far, well done. If you haven't, please do let me know if you are stuck so I can help you. Otherwise, the next step for us is to learn how we're going to run containers from these images locally and have them communicate to each other. Catch me on the next one. Now that we have a Docker image for all of our services, open up Docker Compose, and in here, we're going to add all of these services in here so that we can just say Docker Compose up, and then all of our services will start as a Docker container. So what I want to do first is let's together define both the API gateway as well as Eureka server in here. So what I want to do is I want to create a new service, and I'm going to call this as Eureka dash and then server colon. Then the image will be Amigos code / Eureka server colon and then latest. So this is the latest tag. Then I want to name this container. So container name equals to Eureka dash and then server. Then I want to define the ports, and this is an array of ports, and currently Eureka runs on 8761, and what we're doing here is map 8761 to 8761 on the container. So this port is the host, this is the container. And finally, I want to say that this Eureka server depends on, so underscore on, and this again, it's an array and depends on Zipkin. Now we're not done yet, and I'm gonna basically come back to this in a second, but let's just take this and let's do the same for API gateway. So make sure that it's within the same level, and here Control G and then API GW. So Amigos code, API GW, also latest, container name API gateway, and the port this time is 8083. There we go. And if you don't remember the ports, you can just open up the resources folder, application YAML, and at the very top 8083. So the same for Eureka server. And this time API gateway depends on Zipkin, but also it depends on Eureka dash and then server. And there we go. So what I want to do with you first is I want to make sure that we have both Eureka server and API running together, and then the rest of the microservices, that will be an exercise for you later. Next, let's go ahead and learn about Spring profiles as well as Docker network. If we try to start Eureka server and API gateway, this will not work. And that's because if I open up, so API gateway, and then open up the application.yaml, have a look. So here we have the Zipkin URL, which is localhost. And also, if I scroll down, you can see that we have the Eureka server right here, and this is localhost. Now, because API gateway will be running inside of a container, and Eureka server also runs within a container, localhost will not work because they're two separate containers. And what we have to do instead is use a Docker network. So let's open up the Docker Compose and scroll to the bottom, and in here you can see that we have networks. We already have one for Postgres, so let's just take this, and then we're going to create another one, and let's name it as Spring. Now within the API gateway, we can say networks, and this will use the Spring network. Let's also take this and add it to Eureka server, because Eureka Server talks to Zipkin. So here, so we can do it right after ports. Paste that in. Now, because Eureka Server talks to Zipkin through this network, we have to add this network as well to Zipkin. So here after ports for Zipkin, paste that in, and there we go. So now that we have the network, next let's configure our applications. So Eureka Server as well as API Gateway. Let's configure the application.yamls for both. And right here, I said that localhost does not work. So next, let me show you how we're going to basically use Spring Profiles and update these URLs to the correct ones. So the correct URL that we have to use in order for having the API Gateway to talk to the Eureka Server container and Zipkin container, this cannot be localhost, and instead it has to be the container name. So here, this will be Zipkin, and in here, this will be Eureka dash and then server. Now, this Eureka Server here is, so within Docker Compose, have a look, container name Eureka Server, and the same for Zipkin, container name Zipkin. So therefore here I'm saying Eureka Server and then Zipkin in here. So localhost does not work because they run in separate containers. Now, as it stands, if I basically package my application this way, then I'm actually losing this information, right? So if I'm running things locally without Docker, then this will not work. So let's instead revert this change. And what I'm going to do is I'm going to duplicate this file. So within API Gateway, duplicate application-yaml and then say dash and then Docker. Now this name here, so Docker, right? Application. So application dash. So everything that comes after dash, i.e. Docker, this will be the profile. So let me just say okay. Now here I can change this to Zipkin and this one right here to Eureka dash server. And now inside of Docker Compose.yaml for, so we did it for API Gateway. So here I can say environment, and this is an array of environment variables, and this will be Spring Profiles underscore active equals to and then Docker. So Docker, this Docker name has to be this one. So after dash, so application dash and then Docker. And to be honest, this is it. So let's do the same for Eureka Server. So open up Eureka Server, resources, application.yaml, duplicate this file and call it application-docker. And in here, we only have to update this. So let's just say Zipkin. So this is the container name. So Zipkin. And there we go. Now go back to Docker Compose, take the environment, and then, oh, actually, so I've done it the way around. So this was meant to be for API Gateway, but it's fine. So API Gateway also needs it. So there we go. So both the API Gateway as well as Eureka Server have the environment variable Spring Profiles active, Docker, and within both applications, we added a new file, application-docker.yaml. And with this, we are ready to fire up these two containers and test our changes. Let's go ahead and do that next. So because we've added a new file in here, application-docker.yaml for both Eureka Server and API Gateway, we have to build a new image. Again, we have to build a new image because the current image does not contain application-docker.yaml. So back to the terminal, and in here, let's together run the Maven package build docker image. And this will actually build for every single module. We could have done it for those two specific modules, but that is fine. This time it should be quicker than before because it doesn't have to build all the layers. And if you want to learn more about layers and how this works with Docker, check my Docker for DevOps Engineers course. And there you go. So you can see that this was super quick. Now, what we can do is Docker compose and then up dash and then D for detached. Enter. And this is creating the network right here. And it's recreating Zipkin. Have a look. Eureka server. API gateway. It's starting, and this is because of the dependency. And there we go. Now, if this takes a while for you, it's because I already had this cached, but it shouldn't take that long. Now let's check the logs. So Docker logs and then API gateway. So you can see the response status is 200. Then let's check the logs for Eureka server. So Docker logs, Eureka dash and then server, and running with evict, and it seems to be working as well. So this is our banner in here. So there we go. Next, let's go ahead and open up our web browser. And in here, I've got localhost 8761. So this is Eureka server. If I reload, check this out. So this is working. And you can see that the Eureka server has one instance, which is currently registered, and that is API gateway. Now, if you notice, so in here, the URL, it's no longer 127, so localhost, and this is basically internally to the Docker network. But you can see that it's listening on 8083. Also, Zipkin. So let me just reload, and then let me click on this plus sign, service name, and currently we only see Eureka server because Eureka server is actually sending requests. Have a look, get, post, so on and so forth. Now, if I was to send a request from Postman to our API gateway, so this should give me an error. So if I send, there we go. So service unavailable, API customers, right? So we haven't configured customer nor fraud nor notification. So currently you can see that we have a 503, and back to Zipkin. If I basically clear this and reload and then plus service name, and now you can see that we have API gateway. So right here, run query, and this was, so you can see that it was a 503, service unavailable, unable to find instance for customer. There we go. We've done it. You saw that our API gateway is throwing a 503, service unavailable, unable to find instance for customer. Now, I want to set an exercise for you, and that is within IntelliJ, I want you to basically figure out how you're going to add in customer, fraud, as well as notification microservices to this YAML, and add in the necessary configuration. Give that a go, and I'm going to give you the solution next. And this is my solution. So in here, I've gone ahead and created a new service, customer, image, Amigos code customer, latest, container name, customer, and basically everything the same as the rest. But the network in here, I've added Spring, as well as Postgres, because customer talks to this Postgres container. So it uses this database. Now this is within this Postgres network. So therefore we have to include customer in the same network so that they can talk to each other. Then the same for fraud in here. So fraud, and also, so the port is 8081 instead of 8080. And basically I've also said that it depends on Postgres and RabbitMQ. So all of our microservices do depend on RabbitMQ, and I just want to make sure that if in the future these microservices need RabbitMQ, then there is a dependency between them. Then for notification is the exact same thing, but I've only changed the port. Now you might have seen that within customer src main and then resources we have application-docker.yaml. This is now Postgres, the container name for our Postgres container. Then we have Zipkin in here. We have Eureka Server and also RabbitMQ. So RabbitMQ is the name of our RabbitMQ container. So if I scroll up, so RabbitMQ, and RabbitMQ has to be within the same network for Spring so that customer, if needs to, can talk to it. So that is it for customer. Then fraud. So fraud also has resources, application-docker. So this is basically the Eureka Server container name, Zipkin, and also Postgres. The same for notification. So notification, main, resources, and then application-docker, Postgres, Zipkin, and then here RabbitMQ. So this is the container name for RabbitMQ, and then Eureka Server. And to be honest, this is it. Now what I need to do is build an image for these, and let me clear my screen, dash and then p maven clean package build docker image. There we go, success. Now because we are using latest inside of our Docker compose, so have a look, Eureka Server, the image is latest here. The same for API gateway, customer, fraud, as well as notification. So we are using the latest image. Now what I want to do is pull the latest image from Docker Hub. So here, let me just clear the screen and I can say Docker compose and then pull. So this now will pull the latest images, and you can see that for some of them it already exists, and that's because it's using the cache and layers. So you can see that this was really quick. So now that we are done, let's just run docker compose and then up -d. So created container fraud, customer, and notification, and you can see that there is a dependency between them. And there we go, job done. Now if I run docker ps and then format, and all of them are running, we can check the logs. So logs, and instead of Eureka Server, I'm going to check for customer. Oops, not Eureka Customer, but customer. There we go. So it looks like it started correctly. Have a look, create table, customer. So let's check fraud. Fraud also, create table, fraud check history, and we've got the banner at the very top, if I can see. So there we go, fraud, and we have for customer as well. And finally, notification. So let's check notification. And there we go. So notification started. And also more importantly, have a look, created new connection RabbitMQ. So this means that everything is up and running. Now let's fire up the same request from Postman. And before this request was 503 service unavailable. Let's try and send. And have a look. We have a 200 status code within Zipkin. If I check my traces, so find a trace plus service name. Now we have customer, basically everything. Let's select API gateway, run the query, a few seconds ago with 8 spans, show, and have a look. This is familiar. From API gateway to customer, customer to fraud, and then customer publishes onto the queue for notification, and then notification picks it up. So this is good stuff. Also for Eureka Server, if I reload, before we had API gateway only, now we should see all of our microservices. So this is working. And finally, let's open up pgadmin, and then I have to add in my password. There we go. Open up servers, and in here we have notification. So I just want to check notification because I know we persisted in all of the microservices. So all rows, and check this out. Hi amigos, welcome to Amigos Code. And you can see the timestamp was literally just now. So congratulations, we've managed to take our code, bundle it into a jar, build a Docker image, and then run a container. But more importantly, we've managed to have all of our containers talking to each other. And you can see the beauty of Docker Compose. So in here, let's say that I want to stop everything. I can just say Docker Compose and then stop. So this will stop all containers. There we go. If you want to start, you can say Docker Compose start. Or if you want to get rid of everything, you just say Docker Compose and then down. So this is really cool. So Docker Compose is amazing for testing containers locally. Now, what you could do is, if you didn't manage to get everything running, you can take my exact same Docker Compose.yaml, and then in your terminal or command line, just run Docker Compose -d, and then all of this should work for you. And this is the beauty of Docker. If it works on my machine, it also works on your machine. If you have any questions for what we've done in this section, I know it was quite intense and lots of Docker, but this is pretty much the process that you'll be taking with Java applications and Docker. This is all for now. Catch me on the next one. I'm super excited for this section because we're going to touch on Kubernetes. Now, I'm a huge fan of Kubernetes, and I've got a massive course on Kubernetes which explains everything in detail. But for this course, I'm going to go over the core concepts of Kubernetes. But if you want to further enhance your skills, and maybe you want to become a DevOps engineer, for example, then I've got a specific course just on Kubernetes. Kubernetes is a technology that you should be aware if you want to be a backend developer or a full stack developer. Literally, I think if you want to know how to deploy your code and how it works, then in this section, I'm going to make sure that you understand the core concepts of Kubernetes so that moving forward, you know exactly what we are doing. Let's go ahead and learn about Kubernetes. Kubernetes originated from Google, where they've been deploying and working with containers for many years now. And internally, they have this tool called Borg. Was a very successful internal system that allowed Google to deploy billions of containers every week. From Borg, then they developed Omega, and from Omega, Kubernetes was born. Now, just to note that Kubernetes is actually written from scratch. So it shares the same DNA of Borg and Omega, and the difference here is that it's open source. So everything that developers at Google have learned over the years developing Borg and Omega, they took all of that knowledge and mistakes along the way, and they came up with Kubernetes. So Kubernetes is open source, which means that both you and I can contribute to this awesome project. Fun fact, Kubernetes is actually written in Golang, which is an amazing language. And if you want to learn about Golang, go ahead and check my website where I've got a course on Golang. Now, the easiest way for you to picture Kubernetes is by looking at this picture. So here you can see that we have this cargo, and Kubernetes really, it means pilot. It's a Greek word that means helmsman or pilot. You can see that the ship has a bunch of containers, and then Kubernetes is actually managing all of these containers. Now, if you know about containers and Docker, then this should be somewhat familiar to you. And if you need to learn about Docker and containers, go ahead and check my website where I've got a course waiting for you on Docker. So let's dive a little bit deeper and understand Kubernetes. So Kubernetes, aka K8s, where the 8 is the 8 letters in between K and S, is an application orchestrator. So in this picture, you can see that we have Kubernetes, and Kubernetes orchestrates all of these applications. When we are talking about applications, we mainly refer to containers. So Kubernetes deploys and manages our containers. It also scales up and down according to demand. It performs zero downtime deployments, rollbacks, and much more. So knowing Kubernetes will set you apart from many software engineers, because right now the demand for people that understand Kubernetes is quite high, and the salary as well is super high. So knowing Kubernetes will take you a long step in your career. Now, when we talk about Kubernetes, we need to first understand what a cluster is. So a cluster is a set of nodes, where a node can be a VM or a virtual machine, and these can be running on the cloud such as AWS, Azure, or Google Cloud, or even on premises. Now, when we talk about the Kubernetes cluster, we have to understand the difference between the master node and the worker node. So the master node is simply the brains of the cluster. So this is where all of the decisions are made. And then the worker nodes, this is where all the heavy lifting work happens, such as running your applications. And both the master and the worker node, they do communicate to each other via the kubelet, which I'm going to teach you in a second. Now, within a cluster, you often have more than one worker node. And for this particular cluster, we have 4 nodes in total, 1 master node, and 3 worker nodes. Now that you know what the Kubernetes cluster consists of, next let me go ahead and dive deep into both the master and worker nodes. Right, so you saw that within the Kubernetes cluster, we do have the master node. Now the master node contains what is known as the control plane. The control plane is made of several components, and they are the API server, the scheduler, cluster store, controller manager, cloud manager, which talks to the underlying cloud provider API, whether it's AWS, Google Cloud, Azure, so on and so forth. And all of these components within the master node, they communicate via the API server. And also we do have the worker nodes, but these are outside, right? So the master, it's a node, right? So a VM that contains all of these components right here. And then we have the individual worker nodes, which I'm going to explain what they are in a second. So now let's start by understanding what each of these components inside of the master node do. So let's start with the API server. Now the API server is the front end to the Kubernetes control plane. All communications go through the API server. This includes external and internal. And it exposes a RESTful API on port 443. And also, in order for you to talk to the API, authentication and authorization checks are performed. So in essence, we have the API server. If you're talking externally using kubectl client, which you're going to learn later. So here I'm saying kubectl apply and then F for a file. And this is a YAML manifest that I'm going to teach you as well. So this file is actually sent to the API server, and also internal communication goes via the API server. So you can see that this is a very important component. Next, we have the cluster store, where this really contains all of the state for our application. So it stores the configuration and state, and currently, Kubernetes uses etcd, which is a distributed key value data store. And etcd is the single source of truth. So it's our database, right? So like any other application that you build, the database contains the source of truth. So here, if I use kubectl or kubectl, which you're going to learn in a second. So if, for example, you want to apply a YAML manifest, then that goes through the API server all the way to the etcd store. So etcd contains the configuration for our entire